Alrighty guys, so today we're going to learn about lesson 5.4, circumcenter, right? So what a circumcenter error, and it's on your notes, but I also went ahead and drew it, is if we have triangle ABC, okay? And then what we're going to do is we're going to make 3 perpendicular bisectors. So in case you forgot what that means, is that E is the midpoint of BC, but it is also meeting it at a perpendicular or 90-degree angle indicated by these little squares, right? So each one of these points is bisecting this line at the midpoint and meeting this at a 90-degree angle. Do not worry that the vertices to the circumcenter is not a 90, like you can say this one comes off at an angle then straight down. That's fine, we'll talk about that when we get into our notes. The important ones about being 90 degrees and straight, FP, DP, EP. Alright? So, the perpendicular bisectors, it's going to be the first thing you fill in, of the sides of a triangle intersect at a point called the circumcenter. In this case, we've labeled it P. Okay? The circumcenter is always equidistant from the vertices. So, AP, BP, and CP are all going to be the same. Okay? So that blank right there was vertices of a triangle. All right, then it says, use the diagram to the left to answer the following questions. It says, 1, list the perpendicular bisectors. So, what are our perpendicular bisectors? Well, we have this one right here. We have line segment DP. We have line segment EP. And we have line segment FP. So number 1, DP line segment EP, line segment FP. Name the circumcenter. This is where all 3 of those are meeting, and that is meeting clearly at point P. So P. Finally, list all congruent segments. So I've marked it off nicely so we can easily go through these. So we have AD is congruent to DB. We have BE, whoops, no comma, there's a comma, is congruent to EC, comma. We have AF, congruent to FC, did it again, congruent. And then finally we have AP is congruent to BP, which is congruent to CP. Alright? So this is number 3. Remember, equivalent just means I can tell they're the same size. So congruent, not equivalent, I'm sorry. Congruent means they're the same size, right? I can just look at them, be like, that's the same size as that, but I'm not giving it a unit. So we have a line above it to say it's line segment, line above your letters, line above your equal sign. Easiest way to remember if you're using congruent or equal sign. So, right here, you should have all the notes in that first chunk, and we're going to move on to example 1. All right, so number 1, you should have this drawing. We have triangle TUV, okay? And then Z is the circumcenter. Our midpoints are W, X, Y. And then we were given some distances, right? So from V to U is 34 units. We have X to U is 19. We have W to Z is 15. And we have V to Z is 21. I have a misprint. Mine says just 2. Not sure about your packet. Mine just says 2, but it is 21, just so you guys know. Okay, So, what it's asking us is to find, let's see, TU, VY, UZ, WV, and TB. Alrighty? So, we're going to go write down these and see if we can find any just by looking at it. So, TU. What do we know about X? Well, we know it's going to be our midpoint, right? Because this is a perpendicular bisector. It has to be for Z to be the circumcenter, which it says it is. So if this is 19, this also has to be 19. So we're just going to add 19 and 19 together, which equals 38 units. So TU knocks right off the board, no problem. VY. So let's see, where is VY? So we have VY is here, okay? Again, Y is what? Y is our midpoint. So this must be equal to this. And if we know all of this, it's as simple as saying this is going to be equal to A, and that's equal to A. So we say A plus A is equal to 34, which is saying 2A is equal to 34, which is saying A is equal to 17 units. So VY is equal to 17 units. Let's move on to the next one. We have UZ. So our circumcenter rules say from the vertices to the circumcenter is the same for all vertices. We know that VZ is 21, 3. So this must be 21, and this must be 21. So that one, no math needed, just 21 units. Moving on to WV. So what do we have here? Well, we know that this is going to be the same as this, but we don't know this distance. But what do we know? That's right, the Pythagorean theorem. So this is a right angle. So we have a leg, and a hypotenuse, and we have 2 out of 3. Therefore, we can solve. In case you've forgotten, a squared plus b squared equals c squared, where a is a leg, b is a leg, c is our hypotenuse. All right? What's our hypotenuse? Well, that's going to be 21 squared equals. What's a leg? We're going to say 15 squared plus, and then what's this one? Just for variables, we'll call it b, which is nice. It's for our formula. All right? So we're going to head and square those. 21 and 21 is going to give me 441 is equal to 15 and 15 gives me 225 plus b squared. We subtract 225 from both sides. Those cancel. We're left with b squared is equal to, I drew a big old line through that. That did not cancel. That's subtraction. And that's going to give us, borrow 3, 1. That's a 6, 1, 2. 216. So now we know that b squared is equal to 216. Take the square root of both sides. We get b is equal to the square root 216. That's not an even number. Put it into a calculator and we get VW is about 14.7 units. Alrighty. And finally, we have TV. So TV is our full thing. So since they are the same, we just double this. So 14.7, 14.7 is going to give me 29.4 units. So nice and easy. That's why we went over Pythagorean theorem on Friday. You should be able to add these tick marks to decide what is congruent to one another. And then from there, with either dividing, doubling, or saying they're equal, or Pythagorean theorem, should have no problem solving for any other circumcenter problems. So go ahead and give numbers 2 and give numbers 2 and 3 a shot, and then go over the answers and then move on. Alrighty, so hopefully for 2, you got A was 12 units, B was 14 units, C was 11 units, D was 12.6 units, and E was 25.2 units. For number 3, 60 units, 34, 25, 50, and 34 units. If you did not get those answers, ask a neighbor for help. Maybe they got the right answer. They could explain, show you where you messed up. If you're still having issues, feel free to email me at any time. Otherwise, flip the page. We're going to move on to incenters. Alrighty, so you should flip the page. We're moving on to incenters. And over here, we're going to start here, and I'm going to show you how they ended up with the diagram underneath incenters. So, what it's saying is and then the first 2 blanks are angle bisectors of angles of a triangle intersect at a point called the incenter, the main focus of what we're talking about. And then it says, this incenter is always equidistant from the sides of the triangle. So, I'm going to go ahead, I'm going to bisect this angle. Let's say somewhere right about there. Oops. Somewhere in there, right? That's about bisecting it. And I'll go ahead and mark it to show they're the same. All right, so we got that one and that one. Then I'm going to bisect this angle. Let's say it's right about there. Alrighty. So now I got this one all marked off. And finally, I bisect the third angle. I will get my incenter. Okay. So now I have successfully created my incenter, and we'll call that point P. All right. What it's saying is that the shortest distance from any side to the incenter is the same. What's going to be the shortest distance? Well, it's going to be perpendicular. Right, that's not quite perpendicular. Okay. So that's why the lines don't look quite straight. I've made mine a little bit more askew to really show that it's not a straight line from B to, what's our bottom one? F. There's not a straight line, okay? So we have D, E, and F. Now we have our incenter. And now what it's saying is the incenter is equidistant from any side. So what that's saying is that this is equal to this is equal to this. Okay? Now, what can we say by looking at these? Well, if I look, maybe this will make it a little bit more easier. We'll do this one first. I have triangle, right? F, P, C, and I have triangle. Probably be easier to draw it this way, just so I can keep my sides in line. E, P, C. All right? So the two triangles I'm talking about are this one and this one. Okay? Well, we just said that these are the same, right? We know they're both 90-degree angles. And we know that PC is going to be equal to PC. So what does that give us? Well, it gives us hypotenuse leg, right? So we already said that angles, FCP are congruent to CPD. So these are congruent, and that makes sense, right? We have angle, side. We also have hypotenuse leg. So we're, two ways of proving that these are congruent triangles. So that's the theory behind all this. So if they're congruent triangles, what can we say? Well, then we can say that FC is equal to CE, or a better way to show it on here, that is congruent to that. So you can go ahead and fill in the rest. Pause the video here. I'm going to cut to me having it all shaded out. Alrighty, I realized I didn't need the cut. I forgot that the picture's there. But just to show you with the different colors, AD is congruent to AF. DB is congruent to BE. And then we already said that these two were congruent. And then each of from our sides to P are congruent to one another. So we're going to go through and list the angle bisectors. Well, we have AP. We have line segment BP. And line segment CP. Name our incenter. Well, that's just going to be point P. And now name all congruent pairs. We're just going to go right through our diagram. So our first one we marked off. Whoops, I don't want to put that there. I want to put it here. We have line segment DP is congruent to EP, which is also congruent to FP. Then we have, AD is congruent to AF. BD is congruent to BE. And finally, CF is congruent to CE. Alrighty, so this should be number 1, number 2, and number 3. So hopefully with the shading and breaking up the triangles to show the pairs, this will make a little sense. Easiest way to remember the difference between incenter and circumcenter is if you're going from the angle to a center, the equal parts are going to be the sides to the sides. So if you're cutting the angle in half, the sides are equal. If you're cutting the sides in half, the angles are equal. Alright, so we're going to move on to number 1. Alrighty, before we do number 1, I just want to clarify, when I said the angles are the same, I meant the distance from the circumcenter to the angles are the same. So again, in center, you're dividing the angles, so from the center to the sides are the same. For circumcenter, you're dividing the sides, So from the center to the angles are the same. So whatever you're dividing, the distance from the center to the opposite is going to be equal to all three. All right, let's move on to number 1. And we have triangle JKL, and it gives us that MP is equal to 8 and LP is equal to 13, and asks us to solve for a few of our line segments. So, number 1 is NP. Well, NP, we know because this is an incenter, they're all the same. So right away, we can just say 8 units and be done. All right, number 2, we have NK. So, from N to K, what is it? I see that I forgot one of my measurements. So, NK, what can we say? Well, if we go over here to the one I kept up, these two triangles are congruent. So in this case, BE, BD is the same as KN, KO. So NK is just going to be 17 units. On to PK. All right, PK. So now we actually have to do a little bit of math because we have, yet again, the Pythagorean theorem. So we have 8 squared plus 17 squared is equal to C squared. It's going to give us 64 plus, I don't know, I should have got a calculator. Let's see, it's going to give me 9, it's going to give me 4, it's going to give me 11, it's going to give me 7, it's going to give me 1, 289, sounds right. Alright, add those two together, add the 1, we have 5, add the 1, 353 equal to C squared. Then we take the square root of both sides. And our final answer is going to be C is about 18.8. Alright. So PK is about 18.8 units. And the last one, LO. Again, we're going to have to do Pythagorean theorem, but this time it's 13 squared minus 8 squared is equal to A squared. We have 64 again, 13 and 13. It's 169. Subtract those two from each other. 501, 105 equals A squared. Take the square root of both sides, you get A is about 10 point, what's the final answer, 2? So A is about 10.2 units. Alrighty, so hopefully you're able to follow along with that. Go ahead and complete number 5 and 6 on this page. This was number 4. Pause the video now, do 5 and 6, and then I'll go over the answers. Alrighty, so for number 5, you should have gotten 12, 13.4, 35, and 6. For number 6, I wasn't paying attention. I thought the angle questions were on the next page. So I actually do want to do this one together. So if you gave it a shot, you want to follow along, feel free to. If you gave it a shot and think you have the answer correct, go ahead and skip forward. You can check the answer. If you got them wrong, come back, watch the video. All right, so it says, if S is the incenter of PQR and measurement of PRQ, So this whole angle is equal to 8x minus 10 degrees. That whole angle, all right? And then the measurement of RPQ, so this whole angle, that's going to be 4x minus 14 degrees. Alrighty, and then we have PQR, final one. And that's equal to 7x minus 5 degrees. Find each angle. Alright, so first thing we have to do, solve for x. Well, how do we do that? Well, we got to do something, right? Well, luckily we know that. Add up all the angles of a triangle, you get 180. So what do? You get 4x minus 14 plus 7x minus 5 plus 8x plus 10 is equal to 180. Now we just combine like terms. They're all plus in between, so we can get rid of these parentheses. Right? 7x, and we'll add the 8x in there, so we get 12 19x. Then we have negative 14 minus 5, minus and minus, add them together, take the sign, so negative 19 plus 10, so we're going to have minus 9 is equal to 180. Add 9 to both sides, we get 19x is equal to 189. And that is going to give us x equals 11. Okay? Now, I did some wrong math. We're going to do math wrong. I know it equals 11. Oh, it's minus 10. Minus 10, so it's minus 29. So minus 20, add 29 to both sides. You're going to get 209, which does look a lot more right. Now you get 11. I knew it was 11. Alright, so now we can go ahead and plug x back into each one. So we get 44 minus 14, that's going to give me 30. Over here, we're going to get 88 minus 10. That's going to be 78. And finally, we have 77 minus 5. That's going to be 72. All right. And just to check, 72 plus 78 gives me a 0, gives me 1, it gives me 150, plus 30 does equal 180. So my math checks out. All right. Now we just go through. So the measurement of PRQ, 78, like we said, it's right there, so 78 degrees. B, RPQ, 30 degrees. C, PQR, did that one too, 72 degrees. D, RPS, so let's see, RPS, so it's going to be half of that, so it's half of 30, 15 degrees. E, F, G. Alrighty. Let's see. E, PQS. PQS. So that's going to be half of 72, and that's going to be 36 degrees. F, we have PRS. PRS, that's going to be half of 78. That's going to be 39 degrees. And finally, PSR. So PSR. So we know that this one is 15 degrees. We know that this one is 39 degrees. We add them together. 15 and 39. Add them together. You get a 4. Carry the 1. 54. 180 minus 54. Borrow, add 621. 126 degrees. Alrighty. So hopefully you're able to do number 6, get these answers, 78, 30, 72, 15, 36, 39, and 126. So this is all about incenters. Hopefully you're able to do this. What you're going to do is flip on to the next 2 pages where it reviews circumcenters and incenters. Give those a shot, and then for the end of class, I'm just going to expect the 2 pages on circumcenters and incenters to be done in school. Move on to the homework, and if you're able to get that done, or move on to the next 2 pages, if you're able to get all 2 pages done, awesome. Otherwise, whatever you don't get done will be due for homework. So hopefully this lesson helped, and hopefully you can actually open it up unlike yesterday. Sorry about that. So any questions, feel free to email me. Most of you saw that when you emailed me, it's pretty quick to respond. Just my Schoology app wasn't working on the job site, but my email was. So I think Schoology might have been having an issue, but just to be safe, created my own video, and I'm going to upload it to YouTube and Schoology. So email me anytime, and otherwise, good luck.